All right, welcome to the video. Today we're going to do a fun little Homelab project, which is setting up and configuring a Proxmox high availability cluster. And then we're going to additionally add Ceph distributed object storage on top of it. And we're going to show failover between virtual machines, some things where it went wrong when I was testing it, where things went well, etc. So what we're going to start with is I have a basic Proxmox instance running here, and what we need to do is we're going to create 3 virtual machines within that Proxmox instance that each run Proxmox themselves, and then we will have each of those virtual machines configured as a high availability cluster and use that to show failover. So what we're going to do here is set up each of the Proxmox virtual machines, and once those are set up and running, we will jump in and get the demonstration started. All right, now that we have our Proxmox nodes set up, we can go into each of them and start to configure a cluster. So starting here on the screen, this is my root Proxmox host where you can see the 3 other Proxmox instances we created. You can see on their console that they're just letting you know the web admin site is up and running. So we have these 3 here, and up in these tabs, I have loaded up the admin interfaces for each of these 3 Proxmox instances. So what we're going to do is start on the first one, Proxmox cluster 1. We're not going to install Ceph now. We will get to that in a bit. We're going to start simple now, and we're not going to use the distributed file store. We will just go into the data center configuration. We're going to go to the cluster tab, and we're going to hit create cluster. And we'll just call it cluster 1. Again, we're going to keep this simple today just for playing around in the Homelab environment. So we're going to create the cluster. All right, that is all done. So you can see we have 1 node in the cluster. So what we're going to need to do is go to each of the other nodes and join those. So here you can see there is the join information. So you can open that up. I'm going to click copy. We'll go to the second machine, and then here we will click join cluster again from the data center interface. Paste in the join information, enter the root, the peer password, and click join cluster 1, and it will do that. And we'll swap over to the third machine here while we're at it. Click on the data center tab, click cluster, and same operation, just join cluster again. All right, so both of these nodes have joined the cluster, and we're going to go back to the first tab, the main cluster host, and we should see them all here. And here we go. Cluster nodes 1, 2, and 3. And what you need to do is you need to refresh the browser on these just to show that it's working. I'm actually not even going to log in because we don't need to anymore. So over on this first instance, we can manage all 3 instances in the cluster from one interface, which is really nice. So now that we have a cluster set up, we're going to set up a very simple VM, and we're going to show you how you can do migration between the cluster nodes. Now we're going to do this very simply. We're going to create a VM on one of these nodes, and we're going to have the VM disk stored on local storage. Like I said, that's going to be very simple to set up, but it's going to come with a number of downsides in terms of migration, etc. But it'll just be a simple starting point, and we can show kind of how that works, how migration works, and you'll see that it's probably not the best situation. We'll dive into that a little more. So what I'm going to do now is I'm going to go and not going to install Ceph. Clearly this thing knows where we're going. So we're not going to do that. We're just going to go into the first cluster node. We need to go into the local storage, and we need to first upload an ISO. So what we're going to do is we're going to use this and create a simple Ubuntu server sitting on this cluster node. And so we'll go off and do that real quick. I'm sure you've seen that 1,000 times. All right, now that we have our Ubuntu server up and running, and by the way, they took a really long time to install. It probably took a good hour or 2. I don't know why. Maybe with our Inception setup here, It's not the most efficient thing, but if we go back to kind of our root Proxmox instance, this is it's a Dell 370 XD server with 56 cores and 256 gigabytes of RAM. Not the most new machine, but it definitely has some beef. Anyway, that took a really long time to install, but we do have our server up and running, which you can see here, and it is just ticking away, doing its thing. I'm logged in at the console. So what we're going to do is just show a really simple migration. And remember here, this server has its disk stored locally. So if you go into local LVM, you can see the disk. Now, if you want to migrate this to another node in the cluster, it's as simple as right click and click migrate. Before we go ahead and do that, let's just kind of pause and explain a little bit about what's going on. This is the simplest form of migration. And when you watch other videos out there, they'll get into all the data stores that you can add, like Ceph or NFS, etc. That actually make migration easier, faster, allow you to do live migration, etc. And that's all great, but don't discount the benefits of a really simple environment with simple migration using local storage. So here, the VM disk is stored locally. If you think about what has to happen to migrate the machine to another VM, if you want to move this down to cluster node number 2, there's no VM disk down here. Like there's nothing to get this VM started on. And so basically the migration process really just has to take the entire VM disk, move it to another machine, and restart it. And that's fine. Like, again, if you think about it, like, don't underestimate the usefulness of that. If you have a simple Homelab environment, maybe you just have a couple Proxmox nodes and you want to be able to move VMs around in the event that you need to take some downtime. You don't need to worry about running a distributed file system and the complexity that comes with that. Of course, it might be fun to play with, but just running your VMs on simple local storage and moving them when needed, which may not be very often, this could work for you, and it's super simple. So don't underestimate that. So what we'll do is, just to show this, we're going to right click and we'll choose migrate. And you can see we pick where we want to send it to. And for this, we'll pick cluster 2. And it says migration with a local disk might take a long time, of course, because it's going to have to copy a 16 gigabyte disk to the other host. So what we're going to do is I'll just click migrate and we'll watch what happens. So as you can see, it's just migrating the storage over to the other VM. And remember, we are running in the full inception environment, so I/O is definitely going to be slow, as evidenced by my multi-hour installation time. So we'll let this finish up, and then we'll show you what happens once the VM is migrated over. All right, so the migration is complete. And if you were paying close attention there was actually an error in the first migration. I had to kind of go restart it and tweak things a little bit. Well, the problem was I did not have enough space on the destination cluster for the hard drive. So I went back and quickly added some additional drives, which you can see over here on the left side. I added these VM drives just so there would be a destination with enough space. And then we started the migration again. And you can see, just looking at the log here, I'll zoom in. Looking at the log here, it transferred the 16 gigabytes of disk storage. And then after that, it went and transferred the memory state, the 64 gigabytes of memory state over to the other machine and finished that up. And then if you look back at the console window behind us, the ping we had running, which I started back when this was running on cluster 1 node, is still going just fine. So there is a simple demonstration of a VM migration using local storage. You can see it wasn't exactly quick, but it got the job done. So I was getting ready to transition this video into a section on Ceph and show you how to set up a distributed storage server, which will make migration much better. I stopped recording and I decided to try something just before I logged off for the night. And so if we go back, I showed you how to do a simple migration of a VM from one cluster node to another using local storage, and we watched it copy everything over, and everything worked great. And I was actually curious what would happen in the case of a node failure. What would happen in the case of migration, in that case using local storage. Now, if a node simply shuts down, you wouldn't expect it to migrate it, since obviously it's an unexpected shutdown. The data is stored locally. I think we all know how that would go. But what I was curious about is if I had a VM sitting on local storage and I chose to actually go into the node and I explicitly chose shutdown, would it be smart enough to migrate the VM and then shut down the node? And so what I did was, by the way, to jump to the answer is no. It did not go well at all, and I ended up destroying a VM in the process. I'll just show you what I did. And so we'll get into this more in the Ceph section, but what you can do is if you go up to the data center level, you can set up high availability group, which describe how your cluster will behave in the event of a failure and how VMs will move around in that case. So what I'm going to do, just again, for a quick example, I'm going to create one high availability group. And just for this example, I'm only going to put nodes 2 and 3 in this because these were the nodes with the extra storage I added. And you can set priorities and everything else. We're not going to do that right now. So I created the group, and now I need to add a VM to this group. So I'm going to add server 1. I only have one. That's VM ID 100. And I'm just going to add it to, I think my old group is still in here. Let me just confirm that test group is right. Let's just see. So I added that. Oh, so it should be on test group. There we go. Okay, so I created, I messed this up. I'm going to remove this group. So I have one high availability group with 2 nodes in it. I didn't set any priorities. I added my single VM to the group. And so again, what I wondered is, given this group setup, and we know what will happen is, in theory, if node 3 goes down here, it should move the VMs to node 2. And I wondered if in a managed shutdown process, if that would happen. So I came in, you can see I have my VM running here. It's all good. So I clicked on node 3 and I selected shutdown, and we'll watch what happens. And as this thing shuts down, I'm just going to show you one thing. If we go into the VM storage, you can see the disk associated with VM 100. So you can see down here in the console, it started the shutdown process. And so this might take a minute. All right, so we can see that cluster node 3 is shut down. And if I go back out to my root Proxmox instance, you can also see node 3 is shut down. So we should, in theory, see the VM move over to node 2, since this was a managed shutdown. So we'll watch for that. All right, so we can see we just saw the VM server 1 pop up here on cluster 2. And if you look down here in the tasks, you can see the VM 100 start command. But you'll notice there's a bit of a problem. So VM 100 start, and it says error, no such logical volume. And so let's dig into why that is. And what I'm going to do just to show this, I'm going to go back out to the root instance. I'm going to restart node 3 because we're going to need to look at the storage on that. And this thing is continually trying to restart. So you can see it says no such logical volume, disk 0. So, and then if I go onto node 2, if I go into the VMs, there's no VM disk here. There's no VM disk anywhere. So when I did the graceful shutdown of node 3, it migrated the VM definition, but it didn't migrate the disk associated with it. Okay, node 3 is back up, and we'll go in here, and there is the disk that belongs to the VM sitting over on node 2. So obviously that was a fail, and as it stands, that VM is broken until we can reassociate the disk with the VM definition. But just another example of potential downside. If you're going to go build your Proxmox cluster and you're going to stick with local VMs, you're not going to get a migration that works on shutdown. You'll have to migrate the VMs manually and then shut down cluster nodes yourself. It's a very simple configuration, as I mentioned before, and if that works for your use case, by all means go for it. But what we'll do now now is we'll jump into setting up Ceph and distributed object storage, which will definitely add complexity to the configuration, but it'll make some of these use cases actually work. But we'll dig into that next. All right, now we're going to take a look at using a distributed storage service with your Proxmox cluster, and we're going to use Ceph since that is the fun thing to do. It's probably one of the best options out there, and it's integrated nicely with Proxmox. So you can really go super deep into Ceph. There's lots of information out there, books, tutorials. You could even run a Ceph cluster on your own if you want to go play with it. But just to kind of simplify things a bit and give you a flavor of what Ceph does, you can think of Ceph as a storage service that makes all of your VM disks available across all of the nodes of your cluster. So if you have a VM running on one node, disk for the VM is available across all of the nodes. And you can just see how like having this makes things like migration much easier and faster. And Ceph is actually, it's a standalone service, and it's kind of abstracting the storage and management of disks. And so when you're running Ceph with Proxmox, each node will contribute local disks to the storage service. And you'll see this when we set it up. So you can set up nodes with a bunch of disks and then contribute them to the storage pool, which is managed by Ceph. Each local disk is accompanied by something called an OSD, which is an object storage daemon. And this is responsible for managing the storage on the disk, reading, writing the data, reporting status, and it participates in the replication process because as unsurprisingly in Ceph, your data is replicated and safe, and you can control all those replication parameters when you really get into it. And on top of that, Ceph uses monitoring processes to maintain the health of the cluster and maintain metadata about the overall cluster map and configuration. Again, that's a super, super high level view of what's going on. But when we start to set it up, hopefully it's enough context so to understand kind of the actual pieces we're configuring. So what we're going to do is we're going to set up each of these through Proxmox. We're going to set up the storage, the OSD daemons, and then the monitors. And so the first thing we need to do is configure several disks to contribute to the storage pool. So what I'm going to do is I'm going to go back to my root Proxmox node, which is holding my inception node, which is holding each of the 3 Proxmox instances. And I'm going to add disks to each of those nodes, which then we're going to incorporate with our Ceph service. For demonstration purposes and for fun, just to show a little bit how this works, I'm not going to add just one disk to each node. I might add a couple, and you'll get to see how all these disks come together to contribute to the Ceph storage pool. So we'll go ahead and do this now. So I have right here, I have my kind of root Proxmox instance. Here are the 3 Proxmox cluster nodes we have running. So I'm going to go to the first one, go to the hardware, and I am going to add a hard disk. And I will just put this in local storage. 32 gigabytes is fine. We're just messing around. So we added 1. That's fine. I'm going to go to the second node. I actually have another hard disk on here because I think I mapped this to, I mapped this to the VMs pool from the previous example, but I'm gonna add another one. Actually, in this case, I will add 2. And then I'm gonna go down to the third node, and why not? We'll be creative. I will add 3, and I'll make them a different size. I'll just make them 16. So now that we have the hard drive set up, we need to go back onto these cluster nodes and get Ceph installed. So we'll go to the first cluster node and click on Ceph. And yep, we will install Ceph. And so for here, since we do not have an enterprise license, you want to make sure you pick the no subscription repository. And we're going to pick the latest Reef version of Ceph. And we'll go ahead and start the installation. All right, installation is done. So now we'll move over to the configuration. And here it's asking us to configure the public network for the Ceph cluster. And remember, I described Ceph as it's a distributed storage service. So it can run on its own network, and you can configure the connections and the nodes and kind of build it out in a super specialized way for highly scaled environments. But in this case, we're just running on a simple, very virtualized server. So we will just use the same network and we'll leave everything else as a default with the number of replicas at 3. So we're all set. So the next thing we need to do, as it says here, is install this on our other nodes, create the monitors, OSDs, and then finally the storage pool. So we'll click finish. Now we'll go to the next node and go through the same process. This is going to be a bit easier since we won't need to go through the configuration. It will just inherit that. We need to make sure to choose the same settings again. Installation on the third node is done. Configuration is already initialized. So we are all done installing Ceph on our 3 nodes. And you can see here, this moved over to the Ceph information page. And you can see there is a warning that we do not have any OSDs. So basically, it's not matching any disks, which is not a surprise. But what I'm going to do is I'm going to go back up to the first cluster. And what we're going to do is first, we're going to set up some monitors. So we are going to we have 1 monitor on our first node. I'm going to create monitors on the second and third nodes. And you'll see that show up in a second. Perfect. So now we'll go create an OSD to manage the disk we have in place. We're still on the first cluster node. And if I go to disks, you should be able to see the disks I added before. Okay, so there I was wondering where all the disks were. I added 1 disk on this node. On the second node here, the 2 disks I added, and there was 1 being used. Yeah, so this one for LVM is being used. We use that for the VM storage. And then on the third node, 3 smaller disks. So we'll start on the first node and we will create an OSD. So we'll go to OSD, create OSD. It figures out the disk to use. There's only 1. We're not going to encrypt it. We'll just leave everything by default. And there is our first OSD running on our first cluster node. So we'll go over to the second cluster node and we'll do the same thing, but this time we're going to do it twice because we have 2 disks to add here. And you can see in the dropdown, it sees the 2 unused disks that we added to this node. So we will create an OSD for each of these. And what's left? All right, so now if we reload the OSD screen, you can see we have 3 OSDs in here. And so now we'll get down to the third node and do the same thing, this time 3 times. Okay, we have all of our OSDs created. 1, 2, 3, 6 drives. This last one is just being set up and we'll see this pop in here momentarily. It's all good. And if we go to the data center tab, again, we can see the overall health of our Ceph cluster. You can see here we have 3 monitors, 1 manager process. We don't need more than that right now for this demonstration. And again, if this was actually doing any read or write, we would see this here. And we can see the overall usage of the cluster. So the next thing we need to do is actually create a storage pool so we can put some VM disks in it. So I'm just going to go back to cluster 1. I'm going to click on pools. And we're going to create a new pool. And I'll just call it. So we'll just name this VM pool. We'll leave everything else with default values. Again, you could dig into the information to figure out how to tune these appropriately. But just for playing around and see how it works, we will just leave this default. Perfect. So we have the VM pool up and running. And you can see it on each of these cluster nodes. So just as we described, it's a storage service. Now it is visible to each of these cluster nodes, and any data we put into the storage pool, we'll be able to see in real time from each of these nodes. So what we want to do now, I removed all the VMs from this, so we're going to go through the process of creating another VM. We're going to ensure the drive is stored on this VM pool, and then we can go through and show how we can migrate the VM set up some high availability groups, etc. But first, we'll go through the process of creating a VM yet again. So I'll go off and do that real quick. So now that we have the new VM up and running, you can see it here in front of us pinging away. And over here in the side, you can see how the storage is set up for this VM. Remember, we created this VM pool, which is our Ceph storage pool. And you can see the disk for the VM. Remember, the VM is running here on node 1. You can see the disk on node 1. But again, if you go down to node 2 and node 3, you can see the disk is there as well. So the disk is visible across those nodes. The VM is running. So before we go in and set up high availability groups and show that, let's just show a simple migration and see how long that takes. So I'll right click like I did before. I'm going to choose migrate. I will choose cluster 3 and we'll migrate it. And you can see the ping running in the background. That should continue. And you can see here in the window what it's transferring is the VM state. So this is the memory state of the VM. The disk state is already available across these nodes. There you go, the migration completed. It says a downtime of 79 milliseconds. And so we'll close that. Over here, you can see on node 3, the server is up and running and continuing to ping away. So that was a successful migration. Much, much faster. Even in this highly virtualized, non-optimal environment, like the differences are very apparent. So now let's go configure some high availability groups and show some of the automated failover. So if I go up to the data center tab, click on high availability, we're going to create a group. And this is a group of nodes in the cluster that we're going to configure together as an availability group. Again, if you had a very large cluster with different nodes and different configurations, you can imagine setting up different groups to determine how you want VMs to fail across them, etc. We will just make this simple. We'll call this TG. We're going to put all the nodes into it. All right, the test group is created. Now I'm going to go to the high availability tab. Now I have to add resources to that group. So I'm going to add the one VM we have. I will add it to the one group we have. There we go. So that's queued, and now it's all set. So we have this VM running, pinging away. So what I'm going to do now is test the case that I showed you before that failed completely, where I shut down the node. I did a graceful shutdown, and it completely messed up the VM. So I'm going to go over to your cluster 3 node. I will choose shutdown, and we'll watch the VM and see what happens. By the way, you can see in the console, we should see the shutdown command in here. There we go, bulk shutdown. Right there. So the console is gone. I'm guessing this cluster node is offline. So what we're going to swap back to the high availability tab on the data center, and you can see here, it shows that cluster 3 is in shutdown mode. And I think it may switch to just stating it is dead, but it understands it is in shutdown mode. Here you can see it turned red. So what we're going to watch for now is the migration of the VM. Here we go. So this switched to old timestamp. It recognizes that it's out. So let's see where it decides to put the VM. So interestingly, so we see the VM 106 shutdown happening here. Okay, so it moved the VM up to the first cluster node. And it looks like it did not do a live migration of that. I actually wasn't expecting that. I thought if you do a graceful shutdown, it would transfer the VM memory state over to the other server, but that apparently didn't happen. Now maybe there's a piece of configuration I missed or something else. But when we, just a few minutes ago, when we did the migration, you saw that was a live migration from one machine to the other. In this case, that didn't happen. So while this VM starts up, which you can see here, I am going to go back. Okay, this thing's booting. I'm going to go back out to the outer Proxmox node, and I am going to restart the node we shut down. So you can see in the event of a cluster node shutting down, either planned or unplanned, there is definitely some downtime associated with the VM, live migration, works much better. All right, so our VM is back up and running. Let's try one other thing. So let's go back into our group configuration. And I'm curious, so we have the VM running on cluster 1. I'm curious what happens if we simply remove cluster 1 from the group. I don't know if it'll do anything. Oh, interesting. So there we go. We changed the group definition and it immediately started a migration of server 3 to another place. Now I'm curious if it does this as a live migration. Well, there you go. It did do it as a live migration. It moved it over to the second node in the cluster, which is one of the 2 we put in the group. So that was pretty neat. But I think this is actually a good time to wrap it up. So we've covered a lot of ground. We've gone from setting up 3 Proxmox VMs from scratch, running on another Proxmox instance. We created virtual machines running with local storage and showed how migration works there and how that can go wrong and actually leave the VMs in a broken state. We installed and did a simple Ceph configuration with a number of hard drives, varying the number of drives per host just to see how that works a little bit, set up our OSDs, monitoring, etc. And then we showed how a Ceph cluster helps and supports kind of live migration and faster migration and high availability configuration. This is really just a jumping off point. You can go much deeper into all these topics and really customize this for your particular needs. But again, for a Homelab project perspective, if you're looking for something to do, this was a ton of fun. I learned a lot going through this, and it might cause me to go change my overall Homelab setup because I think I have another old machine running Proxmox in an unclustered configuration. So maybe that'll turn into another weekend project. But I hope this was super helpful. If you have any questions or comments, please leave them below, and we will see you next time.